So for facing the player, we're gonna have another sprite, another animated sprite facing the other direction. Right now, the animated sprite is facing left. We're gonna need one to face right, and it's gonna face left depending on his sprite state, and face right depending on his sprite state. So we're going to implement something very similar to what we have in the player class right now, which is the sprite map. So we're just gonna copy it now and abstract out a better way of doing it later because we're going to have a lot of enemies and we don't want to keep doing the same work over and over again. But for this first one, I do want to do the same work over and over again so that we can see kind of how the abstraction is going to work. So what I'm talking about is just this initialize sprites and get sprite state and have a struct sprite state. So let's just go into our player CC class and kind of copy out what we need. Well, actually, let's start with the sprite state. So we're gonna have in our private data for our first cave bat a struct sprite state, and he's either going to be facing left or right. So I'm going to create an enum for that instead of a boolean. So bear with me as I create that. So it's going to be left or right or last facing. And I could make this horizontal facing, but I'm going to abstract it out more later. So I'll do that in another episode. So our sprite state is just going to take in a facing, and it'll just be facing gets facing. Let's make a variable called facing. Okay, so now that we have that, what else do we need? We need to implement operator less than, and this is where things get kind of obnoxious, but I'm going to do it just this once so that we see where the abstraction is coming from in later episodes. So yeah, let's I guess let's implement this operator less than. We can do it in the header file since it's going to be pretty short. It's just going to be return a.facing is less than b.facing. Since they're enums, we can compare them like that. And since there's only one enum, we don't need to do a cascading if style thing. So that's easy for now, but we're not going to want to do that a lot in the future. So next thing we need to do is initialize sprites. We want to make sure that we get all of these sprites initialized. So we're going to do the same thing we do for our player class. Let me just go ahead and copy these over. And create some definitions for them. So let's see what we can implement for now. So initialize sprites, we want to make sure that we get every single sprite state, but since there's only two, I am going to do a single for loop. So it'll be for int, what's the first one? Let's make our first facing, sorry. Forgot to do that, facing. So go back to here, and for int facing equals first facing while facing is less than last facing plus plus facing. And let's initialize sprite, giving it graphics and sprite state, which will be a facing given facing. No. Which will be a yes, that's correct. Okay, so that takes care of our initialized sprites, which is a lot like the player's initialized sprites, except it's only one for loop instead of 3 for loops. So for initialized sprites, this is where we're going to do this logic, this sprite creation logic. So we're going to need a sprite map too. So I'll put that in here, and this is going to be the exact same as our player's sprite map, except with a different sprite state, because this one's the bat sprite state. Yeah. So this is going to replace our sprite, so I'll get rid of that for now. I'm going to first cave bat cc, and so what's our sprite map called? Sprites. So I'm going to change these to like we have them in the player, so get sprite state. Yeah, let's make get sprite state const. I don't know why it wasn't const, but okay, so sprites. So we're getting a sprites is undefined probably because we didn't include map. Let's see how this looks. Okay, sprites is defined. Although it doesn't do const when we do that, so we'll do .at so we can have const. And we're going to be updating our sprites, get sprite state. Okay, now so instead of initializing this one sprite in the constructor, let's call initialize sprites with graphics, and then initialize this in the initialize sprite method. So this will be sprite sub sprite state equals that. So this will initialize them both to be the left facing bat, but we want it to change based on the facing, so which is going to be the y direction. So tile y if right, here's some pseudocode, if right then tile y equals 3, otherwise 2. So let's create a tile y. So this will be units of tile called tile y, and that's going to be equal to sprite state dot facing is right, then 3, otherwise 2. And we'll make constants for this in a minute. And that's the tile y, so that's down here. Okay, so now we need to implement get sprite state. Get sprite state is going to need to know what direction the bat is facing. So let's create a private data to store that. So this will be, I'll just do this down below our flight angle. So we'll just call this facing. And let's initialize it in our constructor. So facing we'll have it facing the right. It doesn't really matter because it gets set in the first update call anyway. It just matters that it gets set to something. So for get sprite state, we're just going to return sprite state given facing. Okay, now I'm going to build and run to make sure everything's still working right so we can fix any errors. So it says here I'm missing a parenthesis, and it says here I'm converting from double to units of game. I'm okay with that. Okay, so the build succeeded. I'm going to run it just to make sure everything is still working, and it's all still working. So let's go ahead and make sure that the bat is facing the player at all times. So to do that, we're going to need to take into our update method the player's center position. So this will be in game, so player X and units of game. Actually, all we need is the player X, so that's all I'm going to take in. So let me update our .h file. So my methodology is concrete now and abstract later, so we can't obviously do this for all enemies, but we'll figure out what we need to do later. So if our facing needs to be set to be if our center is greater than the player center, face left. So what's our center going to be? Our center is going to be x plus 1/2 of the one tile unit. So units tile to game 1 divided by 2. So if that is greater than the player center, which I'm going to assume that player X is at the player center, then we set our facing to left. Otherwise, we set our facing to right. So now let's fix our game class, game CC, to actually use game CC to make sure it's calling our new method with the proper data. So here in our update method, we need to pass in the player's center, X. So I'm going to create a getter in our player to make this easier. So we'll just call center X and create that in our player. So player.h, and this is just going to be very similar to how we just defined our bat center. So this will be in units of game, and it's going to be called center X, and we can just define it right here, and we can return X plus tile to game 1 divided by 2. And let's make sure that this is const, because it's not affecting anything. Alright, this should be all we need, so I'm going to run it and see how it looks. Make sure it all builds perfectly. It does, so I'll hit F5. Okay, so the bat starts out facing to the right, which is how we defined it. And as soon as we switch over past it, it follows the player. And this looks so good! It's amazing! It's so wonderful. Okay, but we aren't colliding with him yet, but that's going to come soon. And it'll be a fun game. I guarantee it. So thanks for watching, guys. This has been our first enemy. This is a big milestone. So yeah, thanks for sticking with me. Happy developing. Seriously, happy developing.